Okay, so we are doing quadratic functions. Y'all, quadratic functions you have done before. None of this is new. Yes? Okay, so our equations. Vertex form is y equals a x minus h squared plus k. No. Standard form is y equals ax squared plus bx plus c. Okay, so a affects, like if it flips, so reflection. It also can make it wider or skinnier. And h comma k is your vertex. That's why we call this vertex form. Okay, now before we go any further, I want you to flip to the back of the front page of your packet where it says IHOD over. I'll go back there in just a second. IHOD, does anybody remember what IHOD stands for?
Inverse.
And inside. So inside either parentheses or your house, it's a horizontal change. It's opposite of what it looks like, and it affects your domain. So if it's inside, it's your left or right. Okay, and then it's opposite. So yes, to the left is your negative numbers, but in your formula, your equation, it's going to look positive. To the right, it's going to look negative. That's what it means by opposite. Okay. Now, over stands for outside. So outside the parentheses or the house. Vertical change, it's exact, and it affects your range. It's on the back of your front page. So exact, up is positive, down is negative. Mm-hmm. Okay, so flip back to your notes. Okay, so knowing that, we're going to get started. Now, when I say changing, the IHOD over is comparing your parent function to your new function. So let's talk about our parent function first. So using our calculator, we're going to type in our parent equation, and we get x squared. This is the simplest quadratic equation possible. Okay, your parent function is always the simplest. So we're going to hit second graph, and we're going to go to our table. Now, what I want you to realize is looking at this, you don't see it, but I'm going to remind you what this is in a second, but you are going to look for your rainbow. And by rainbow, I mean this. Do you see how 1 and 1 match, 4 and 4 match, and then 9 and 9 match? That's what I mean by your rainbow. So every time you're graphing quadratics, you want to find your rainbow first. Yes? So knowing that, I'm going to fill in my table. -3, 9. -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. Oh, I did not do that right. This is 0. I said 0, 0, I think. Anyways. Oh, I'm going to, hold on. So with our rainbow, these match. So if you're ever given a table and it says to complete it or fill in the missing, you can use your rainbow to figure it out. So if that's 9, this has to be 9, and it's counting by ones, so this has to be 3. So if you weren't given your equation, you can always finish your table by using the rainbow. So we can plot those points. -3, 9. -2, 4. -1, 1, 0, 0, 1, 1, 2, 4, 3, 9. And connect our dots. Now, this rainbow represents our symmetric pairs, or symmetric points. It can be called a couple different things, but it always will say symmetric, yes? And another way we know they're symmetric is when the y is the same. Y is the same. Well, don't these both have 1, 1, 4, 4? Isn't it the y that's matching? Sometimes we also say same height in our table. Okay, so these are the same height. These are the same height. These are the same height. So those are all also symmetric pairs. So that's the difference between looking at the table, looking at the graph. Cool? You can take it if you need to. Okay, so knowing that, let's talk about our domain. Your domain is your left to right, right? Well, with quadratics, it's always going to be the same because they're always U-shaped and they're always going to keep getting wider. Whether it's quickly or slowly, it doesn't matter. Your domain is always -infinity to positive infinity. Because if I continue this graph, doesn't it keep getting wider slowly but surely? Yes. So it's always -infinity to positive for quadratic graphs, for U-shaped graphs. Now range, what's the lowest this goes? 0. And what's the highest it goes? Up forever, so infinity. And remember, your number always gets a square bracket. So remember, range is your height, and it's your lowest to highest. Okay, we're going to kind of skip around over here. Now, the vertex. Do you remember your vertex is the point in the middle? It's always the point that doesn't have a symmetric pair. So that is my vertex. On your parent function, it's 0, 0. And AOS stands for axis of symmetry. Okay? It's always an x equals equation. So it's always going to be x equals a number. Okay? And it's always the x of your vertex. So what's the x of my vertex? So my axis of symmetry is x equals 0. And this is if you were to cut your u in half. Where does it cut in half? It goes through the origin. That is your axis of symmetry. Now from your table, you can always find this as well because your vertex is the center of your rainbow. And the x of your vertex is your axis of symmetry. So you can find all that in your table as well. Now, is this a minimum point or a maximum point? It's a minimum, not a maximum. Does this graph touch your x-axis? Where? Yeah, and remember your x-intercept is where y is 0 and your y-intercept is where x is 0. And on this one, it's actually the same point. Something I do want you to understand, though, is that if I were to shift this graph up, would it touch the x-axis? No. If I had to shift it down, how many times would it touch? Twice, right? Because there's two sides. So what I want you to realize is that you can have two x-intercepts, you can have one x-intercept, or you can have 0 x-intercepts. Yes? Okay. Now, you'll always have one y-intercept. Okay? So knowing that, our graph description is it's U-shaped. So this is all the definitions and things that we need to know for this. Okay, so let's look at number 1. So if we graph it, we have x minus 2 squared minus 1. I typed it the exact same way it was given to me. And I'm going to go to my table, and I'm going to look for my rainbow. So there's my rainbow. Those are the points I'm plotting. Okay, so I have -1, 8, 0, 3, 1, 0, 2, -1, 3, 0, and then 4, 3, and 5, 8. What transformation happened from the parent function? Right 2, down 1. Okay, did it get wider or skinnier? No, it didn't reflect, it didn't flip upside down. Because there's no number in front of A, I knew that right away. Now, one thing I like to write on my paper is I had over, because the biggest thing that helps is I put I had in parentheses. This is opposite, and this is exact. So I could have told you those transformations before we even graphed it if I wanted. Now, what's my vertex? 2, -1. Okay, H is 2, K is -1. I want you to realize H comma K is your vertex. That's why we call this vertex form. But remember, when I plug in H, doesn't it look opposite? Inside is opposite, outside is exact. Yes? Now, what's your axis of symmetry? X equals 2. Is it a minimum or a maximum? What's my domain? We said -infinity to positive infinity every single time with quadratics. Now my range changes a little bit. What's the lowest this graph goes? And what's the highest it goes? Infinity. It goes up forever. And remember, your number gets a square bracket. And what point is symmetric to -1, 8? 5, 8. Pretty basic, yes? Questions, comments, concerns about any of this? Okay, the biggest thing I want y'all to understand today is domain and range and your transformations. So on the rest of these, that's what we're going to focus on, yes? Okay, because I don't want to take up too much time spending it all on the little things that you already know. I'd rather focus on the newer, it's not really new, but newer things, yes? Okay, so let's look at this one. Now, before I even graph it, we're going to talk about the transformations. What do you think the negative tells me to do? Flip. Okay, we call that a vertical reflection. Or you can also see it as reflect over the x-axis, because didn't it flip over the x-axis? So you can see it both ways. Okay. What does the 1/2 make it do if you had to guess? So it makes it smaller. It makes it smooshed vertically, which makes it wider. It makes it like look fat, okay? Because it's growing slower, okay? So we call that a vertical compression. I just put V for vertical instead of spelling it out over and over. So look at my rubber band. Vertical is up and down, right? So if I expand it vertically, didn't my rubber band get skinnier? Vertically. What if I compress it vertically? It got wider, right? So my graph is going to look wider. So negative, I'm just going to do 1 divided 2, x plus 1 minus 1. Oop, don't forget you're squared like me. And when I hit graph, do you see it reflected? It compressed. We didn't keep going though. What else did it do? It got wider. The 1/2 made it wide. What did this plus 1 on the inside make it do? Left 1. And what did this one make it do? Down 1. So it also went left 1, down 1. Okay, so we're gonna plot some points. Now, do I want you to plot these fractions? I mean decimals? No. Y'all just plot your pretty points. We're not gonna plot all of them to save time. -3, -3. Then we have -2, -1, -1. And then we have 3, 3. I mean, sorry, 1, 3. Don't listen to me. Okay, what I want you to realize is that it, you see this first change from the vertex to the next point? How much did it change from -1 to -1.5? 0.5. What's your A? 0.5. So do you see how that is reflected, like it's the same? Guess what number can I put right here if I didn't have a number? Can I put a 1? How much did this change? Didn't it just change 1? So that first change from your vertex to the next point is your A value. Okay? That's how you can always find it if it's not given to you. Now, domain. What's my domain always? Negative infinity, positive infinity. And what's my range this time though? Negative infinity, because it goes down forever. And what's the highest it goes? -1. So that flip-flopped just like my graph flip-flopped. Now, is this one a maximum or a minimum? Okay, so that's what I wanted to talk about on this one. It says x-intercept. How many x-intercepts do I have? 0. Do I put 0? No, because if you put 0, y'all, you're telling me the middle or on the line. Please don't put 0. Yes, you could put none. You could put a big X. You could cross it out. I don't care, but don't put 0. Okay? It does have a y-intercept. It's a ugly point, but you can always look on your calculator. It's 0, and then -1.5. So your y-intercept will always be given to you in your calculator. Any questions on that one? We're not going to answer the rest. Yes? Okay, flip to the back. Okay, this one we're actually not going to graph it. And it's because I want to show you that you can find everything you need from the table without a graph. Yes? So first things first, we always want to find our rainbow. So look, I have 0, 0, and I have 3, 3. Now, I'm always going to continue my graph if I'm given more numbers on one side. So if this is 8, what should the next number be? And if this is 15, what should my next number be? And if this is 24, what should my next number be? 24. And what is the x counting by? 1. So what comes after -3? And then -1, and then not -0, sorry, just 0. So I continued my graph. Or my table. I have everything I need. So we're not going to talk about the equation yet. We're going to talk about all the other stuff. So what's my vertex? No. The center of my rainbow. -5, -1. Center of your rainbow is your vertex. And your axis of symmetry is always the x of your vertex. So we already know those. Does this one have a minimum or a maximum? So you're going to look at your vertex. Is your y your smallest number or your biggest number? Yeah, -1 is the smallest number here, meaning it's a minimum and not a maximum. Do y'all see that? Okay. What's my x-intercept? How do I know where my x-intercept is? It's where y is 0. And you'll see I have 2 of them. -6, 0, and -4, 0. What's my y-intercept? That's where x equals 0. There is always a y-intercept. We continued our graph and we found it, right? 0, 24. If we wouldn't have continued our graph, would we have found it? No. Domain is always what? And what's my smallest y value? -1. And what's my biggest y value? Well, doesn't it keep going? So it's going to be infinity. What's the symmetric point to -10, 24? 0, 24. Okay, so now that we got all the little things, those are super simple to find. The equation is a little harder, but it's not bad. So equation in vertex form. Well, we know, isn't it the opposite of this on the inside? What's the opposite of -5? Because I have a minus, and if I plug in a negative, it becomes positive. And then what's exact y? Now, the last question is what my a value is. I know it has a minimum, so it's not reflected. There's no negative. But did it grow? What did it grow by from the vertex to the next point? -1 to 0 is how much? Just 1. So can I put a 1? Could I have also put nothing?
Yes.
Yes. Do y'all see what I'm saying? That's how you find your vertex form. So we know that all this did was shift left 5, down 1. Any questions with that? Okay, on the last one, the only thing we're going to talk about is the equation in vertex form and transformations. Because is my equation given to me in vertex form? No, it's in standard form. So we're going to type that in our calculator. 2x squared minus 4x plus 2. And I'm going to hit graph. What do you notice? Well, let's look at our table. Let's find our rainbow. What is my vertex? 1, 0, right? So what did it shift? It went right 1. Did it shift up or down? No, because my height is 0. What else happened from the vertex to the first point? How much did it change? So your A is 2. So that means that it's growing faster and it's going to be skinnier, y'all. So this is a sketch. I did not plot any points other than my vertex. Okay, that we call that a vertical expansion. Okay, vertical expansion. So for a vertex form, we have y equals a is 2, parentheses. Did it have a left or right change? Yes, it went right 1, so the opposite of that is -1. Did it have an up or down change? No. So watch, we can type that equation when you're given a different form into your y2, and you can go to your table. Did all the y's match?
Yes.
Then we did it correct. Okay, so that's all we're going to do for that note page.